All right, here we go. The semester 1 review for pre-cal. We're going to start in chapter 1 with functions. This would be a piecewise function, and if you're ever asked to evaluate f of something, remember that something is an x value. So what you're supposed to do is figure out what x restriction does this fit into, because these are just domain restrictions back here. So is -3 less than -1? Well, the answer is yes. So guess what? That is the function that you're going to plug -3 into. And that's really all you're going to do. So 2 times -3 minus 5 would be a -11, and that's your answer. Okay. Now f of 0, well, where does 0 fit? If you read all of these, it looks like 0 goes with the second one. So you're supposed to figure out 3 times the cosine of 0. Unit circle, guys. The cosine of 0 is just 1. So 3 times 1 is 3. And then the last one is 1.4, which is, of course, greater than 1. So you're going to plug into this function. Now, this function, if you don't remember, is called the greatest integer function. So what you're supposed to do is, first of all, just do PEMDAS stuff in here. So 2 times 1.4, that would be a 2.8, and then minus 1, so that's a 1.8. Now, 1.8 inside of this function, it's kind of like a round down function. So 1.8 would round down to the nearest integer, 1. This turns into a 1. So 4 plus 1 is 5, and that would be your final answer. The next one, describe the transformations. Okay, so to do that, we have to know our parent function, and then it says give the domain and range. Well, the parent function is, I always like to write that out. The parent is the absolute value of x, and then I just go left to right. In the front, there's a negative, which means that there is an x-axis reflection. If there's ever a number inside the parentheses, you're going to be moving left or right, and it's the opposite of what you think. So a +4 would make this go left 4. On the outside, that'll be your vertical translation, which is down 3. Okay, so that's pretty much it. Domain and range, if you had drawn this picture, I like to draw it so I can see. Left 4, down 3, there we go. So it looks something like that. Domain is going to be all real numbers on this because there are arrowheads here keeping it going left to right forever. So either all real numbers or -infinity to +infinity. When you go to do range, you just need to look for how low does it go and then how high does it go. Now this goes as low as -infinity, and the top of it is going to be the top of the vertex, which happens at -3. How do I know that? Well, that was the transformation, okay, down 3. So that would be it. Notice I used a bracket there because you get to land on that. All right, moving on to number 3, sketch the function given, decide if it has an inverse, explain why you know that. Okay, let's just start with that. I'm first going to sketch this, and it's not going to be perfect, but this is a parabola that has been vertically stretched and then shifted down 1. And I'm just using transformations to do that. So it looks something like that. Now, to know if something has an inverse, it has to pass the horizontal line test. And so my brain is thinking, does this pass the horizontal line test? Well, no, it does not. Because if I draw a horizontal line, I cross the graph more than once, which means it is a fail. And if it's a fail, then we are not going to have an inverse function. Okay? So I'm done with that one. Okay, the next one is a cubic graph. So when I draw the cubic graph, the parent looks like that. So it's reflected, and then it's moved to the right too. Once again, I'm just using transformations, okay? So it looks something like that. Does that pass a horizontal line test? Yes, it does, which means yes, there's an inverse, okay? And it says that if there's an inverse, that you're supposed to find the equation of the inverse. The way that you're supposed to do that, guys, is you're supposed to switch the x and the y. So I just recopied this, but I literally like flip-flopped those, just switch the x and the y. Then the goal is to get the y by itself. So you just do a little bit of backwards math, a little bit of PEMDAS here to figure this out. I need y alone, so let me take the negative off first. Then I need to get rid of the cubed root, so the cube, so I'm going to cube root both sides. and then that's going to cancel that out. And then my last step looks like I just need to add the 2 to the other side. So there you go. There is the inverse function. Oh wait, and then what else did it say? Give the domain and range of the inverse function, and then describe increasing and decreasing. Ugh, okay. So the domain and range is just going to be, the domain is going to be all real numbers for this. And actually, I think on this one, the range is also going to be all real numbers because it's a cubed root function. And some of y'all might remember that it looks something like that. That's just knowing your parent functions. So even if you move this around and flip it and all that good stuff, it's still going to go to all real numbers. And let's see, with a negative, it's going to reflect across this way. So it's going to look something like this. Okay, so if it looks something like this, it looks like it's decreasing the whole time. So that would be how I answer this question. It is decreasing for all real numbers because you noticed it was going down as you read it from left to right. That's not a huge deal. If you're stuck on those, we can look at a few graphs and do those, some more of those. Is the function blah 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 even, odd, or neither? And describe what type of symmetry it has. So there's so many ways to do these. If you have a calculator, I would honestly just type it in and look at it, right? Because that's the easiest way. If you do that, you're going to notice that it has y-axis symmetry. And if you have memorized that anything with y-axis symmetry is an even function, then you are finished, okay? Now, if you don't have a calculator or you had not memorized that, hopefully just looking at the exponents, you would see that every term has an even exponent. Even the one at the back has an even exponent because behind that one, where am I? Behind that one, guys, there's an invisible x to the 0, okay? And so 10, 4, and 0, we're going to call those even numbers, and so it's an even function, okay? That's important to know because if this had been odd, this had been odd, and that 1 was still there, this would be a neither function, because even though that's odd and that's odd, this has that invisible even power behind it. So it's a mix of even and odd, so it would be a neither. So just kind of keep that in mind, okay? Awesome sauce. All right, number 5. Given blah and blah, find the following. Okay, so this is the composition of functions. We're going to start from the back and work to the front. So first I'm going to plug 1 into G, and when I do that, 1 into G, that's what I do. It's going to be the square root of 9, which is 3. And then that F's in front of it still, so now I need to plug the 3 into the F. And so when you do that, it looks like you're going to get like maybe a 26. Okay. F over G. So to do F over G, all that you are going to do is literally write F over G. Now the kicker here is that you have to be careful with your denominator because remember, you do not want this to be undefined. So what I would do is it's also a square root, so you don't want it to be negative. So out to the side, I'm going to do a little bit of work here. I'm going to say 2x plus 7 better be positive. It better be bigger than 0. And then I'm going to solve that. Square both sides, move the 7 over, divide by the 2, and you're going to get that. So the answer is this, but you also need to write the restriction next to it. So just keep in mind, you got to check your denominator to make sure that it is defined. All right, part C. What are we doing? Part C, part C. Okay, so this one looks horrible. We are going to take back to front. So G gets plugged into F, and then all of that gets plugged into G. So let's just take it one step at a time. G is this equation, so I'm going to take that equation and shove it into F anywhere I see an x. So this will become 3 times the square root of 2x plus 7 squared minus 1. Yay! Okay. Now, before I do the next part, I'm going to clean this up, guys, because when you square a square root, they go away, and then you can distribute the 3, right? So it's really 6x plus 21 minus 1, or 6x plus 20. All right, now, this is now all of that, okay? Now there's still a G in the front. I should erase that circle. It'll mess people up. Okay, so now there's still a G in the front, so we're going to plug all of that into G since it was on the very outside. So into G, I'm going to come up here, replace this X with all of that. So the answer is going to be 2 times 6X plus 20 plus 7. And once again, you want to clean this up, so let me distribute 12X plus 40 plus 7. So that would be the final answer on something like letter C. All right, next video is going to be the next section, unit circle.